if you were driving to the future here somewhere and you're driving and you get that sinking feeling because when you look in the mirror, the rearview mirror, you see the flashing lights and it's a police car pulling you over. How would you respond? I want you to listen carefully. How would you respond if the officer came up to your car, you roll the window down and says, I'm sorry, had to pull you over today because you were going 50 miles in a 40. You're going 50 miles in a 40. Now, what would you be thinking? What, say again? What? 50 miles in a 40? 10 over, you should get a ticket. Oh. Don't get your license anytime soon, Bree. 10 over, if you're going 10 over and they catch you, I'd say 95% of the time you're getting a ticket.
We have to catch you.
They do have to catch you. They have to actually see it, right?
Yeah.
Hey, hey guys, listen up, please. Hey, I know. Listen, hey, ladies. Sorry. I know that analogies are kind of a double-edged sword because I like to try to use analogies to help you understand why you would study something like this, but then it always seems to cause, especially you two ladies, to just like go on these random tangents where you won't stop talking and giggling. It's hard to like learn anything when that's what you're doing. So if a police officer pulled you over and said, I caught you going 50 miles, you wouldn't want to say this. Please, for goodness sake, don't say this. But doesn't that the police officer have his units all messed up?
Yeah.
You're going 50 miles. I had to pull you over for going 50 miles. That actually makes no sense. Does that mean if you drove 50 miles from your house, you should get a ticket? Instead of him saying you were going 50 miles, what should the police officer say? Should be miles per hour. He should be saying that your rate of travel, your speed essentially, right, is higher than what it's supposed to be, so therefore you get a ticket. So if we look at some guy running like I have in this little picture here, if we were to say that he's running at 15, what would be the rate units to go along with this? Maybe miles per hour. That's pretty speedy, but it's definitely possible. It'd be miles per hour. That would be an example of a rate unit for speed, for velocity, running fast, right? Mm-hmm. So population. As we all know, our population worldwide is very much growing. Asia in particular, right? Huge growth in population. What kind of rate units would go if I said, like 5 million? If we're talking about a rate, what kind of units would go with a number like that?
Per year.
What per year? 5 million people per year. Yeah, that would make sense if we're talking about the rate of growth of some population. 5 million people per year. Did you notice that in both cases I said the word per? Miles per hour, or miles divided by hours, or people per year. These are examples of rate units. Okay, these are how fast something's changing. There are other ones. So if we look at this other page of pictures, food consumption. It's a lovely picture. Could look like some of you. For the pizza right next to you or something, right? Ready to go for the pizza after the burger? Who knows? So what if the number here was 3? And we're talking about the rate of food consumption. What rate unit might go with this number and picture? Burgers per minute. I love it. There we go. Burgers, that sounds about right. 3 burgers per minute. These are either small, these are sliders, or you are an incredibly fast eater. One of the two. So again, do you see that word per? Doesn't that mean fraction, essentially? Burgers over minutes? Okay, and then the last one, financial stuff. You can see that the vertical axis is measuring money in dollars. The horizontal axis is measuring time in months. So what kind of rate unit do you think would go with this, Bray?
Is it $100 or $100,000?
let's not worry about the number yet. Well, we can get into the number in a second. What kind of units would go with it? Like we just had burgers per minute. Say again?
Per year.
But I think the time is probably months. What per month?
Money.
What unit for money?
Dollars.
Dollars. Yeah, there we go. And you could say dollars. Dollars, there we go, per month. And you can maybe see that in this particular graph, whoever's dollars these are, it's not going well, is it? In month 0, they had $800. And then by the time December rolls around, 12 months later, they only have $200, right? So I wanted to get just a tiny bit more detailed here. We could actually get a pretty good number for this. Oh, come on. So let's try to connect this back to something we've done in the past. So right here at at month 0, this would be 0, 800, wouldn't it? When the month is 0, there are $800 in this person's bank balance. And then how many months go by? We got
12.
1, 2, 3, 4. I want to make sure I count this right. 6, 7, 8, 9, 10, 11. Perfect. So 12 months go by. 12 months go by, and now the bank balance is at 200. So we can actually get a really good number here, an accurate number. What do you think the average rate of change, how do you think we could calculate the average rate of change here? Let's connect this back to something we've done with lines in the past. What about this line would indicate the rate of change? The slope. There it is. So isn't the slope the change in the y's divided by the change in the x's? So I could write something like this. 200 minus 800 divided by the months would be 12 minus 0, right? So 12 minus 0. So this is negative 600 over 12. You guys know what 600 divided by 12 is? 50, somebody said. Yeah, so it'd be negative $50 per month. So that slope of that line is the same as the average rate of change of the dollars per month. So this person is losing how many dollars each month? 50. Yeah, for whatever reason, every month goes by, they got $50 less. So how many months later would it take for them to have $0? If they keep doing this, 4 more months, and they've got nothing, right? $50 lost per month. Okay, so the idea here is rate units. Rate units would be miles per hour, people per year, burgers per minute, dollars per month. Yeah, that's my favorite one too. Those are all examples of rate units. Okay? I think we'll do one example here. Let me pick the one example I want to do, and then that'll leave us in pretty good shape for later. I am going to say, let's do this one right here, number 2. Number 2. So flip over a page to number 2. So this says there were 45 people in the stadium at 5 p.m. At 7 p.m., there were 2,562 people in the stadium. What is the average rate of change of people in the stadium from 5 p.m. to 7 p.m.? Okay, so can anybody identify the 4 most important words as far as understanding what we're supposed to do? Look up there. If you're looking at me, you're really looking at the wrong thing. Look up there. There's 4 words that say, do this. That's only one word. Yeah, there we go. Average rate of change. So when we see these words right here, average rate of change, that's telling us that's telling us exactly what we need to find, right?
There's 2 ofs.
There are, and so are you thinking multiply?
Yeah.
So I would say, the way I said it before, as I said, of almost always means multiply, and it almost always does. Here, I would say the second of could maybe be construed as multiply, but the one that's highlighted in gray is just a preposition. That'd be one of the rare examples where it's not any kind of multiplication at all.
It says of people, so maybe multiply with the people involved.
Well, let's break this down. Let's keep breaking this down. I think you're getting a little bit too detailed. I want to look at this phrase that I've highlighted. I want to look at this phrase as a whole. So I want to look at the whole phrase, average rate of change. And this is what we just got done talking about with that bank, like the bank statement or the bank balance thing. When you see the words average rate of change, what did we do with that graph just like 2 minutes ago? Okay, look back. What did we find? I said, what's the average rate of change of this person's bank balance? You all said it. I said, what do you think we should do? And you said we should use the?
Divide.
Yeah, because division is involved in finding the slope, right? So here is how you interpret this. If you see find the average rate of change, this means find or use slope, which does involve division, right? It is the change in the y's divided by the change in the x's. Okay. Doing okay? We just did this 2 minutes ago, so I'm hoping you'll be able to see this good connection. So I'm going to find my slope. My slope is the change in y's divided by the change in x. The only issue with this is that I don't have any x's and I don't have any y's. I've got people and I've got time. So we got to decide. There is a right way to do this, and there is a wrong way to do this. Do you think, well, let me just phrase it like this. Where do you think time should go? Do you think time should be in the numerator? Do you think time should be in the denominator? Time should always be in the denominator. Did you notice in all those examples before it was miles per hour, people per year? That's a time unit. Burgers per minute. Time's in the denominator, right? The last one was dollars per month. Time always goes down there in the denominator. Do you know why? That's right. Time does not depend on anything. The independent variable goes down there in the denominator, and time is probably the most independent of things. It just marches on no matter what you're doing or not doing. It's independent completely of whatever's going on. Okay, so if I'm going to find my slope, I am going to then say, all right, time is in the denominator. What is my second time? 7 p.m. Minus, what is my first time? Say again? 5. So that's time 2 minus time 1. And then in the numerator, that's where all the stuff about the people is going to go. What was the second number of people? What came second? Bray? Yeah, the big number, right? The stadium's filling up. So there'd be 2,562 minus, what was the original number of people? 45. Bless you. It's almost empty. The stadium is. And then a couple hours later, it's pretty full. Makes sense. So what we would do here is we would probably break out the calculator and do a little subtraction. I think this ends up being 2,517 divided by 2. And then, let's see here, 1258.5, I think. Everybody else, did I do that right, Chase?
What?
I was asking, it looked like you were pushing buttons on a calculator.
I pressed the wrong button.
Oh, okay. I think this is 1258.5. What kind of units would go with that number? Say it again, Bree. People per hour. Hey, ladies. Or maybe I should just say more specifically, Ellie? Okay. The only reason why I say this, I just want you to get this. It would be people per hour. Bree said that well. You should be able to get your units straight off of your slope expression. Wasn't the numerator all about the number of people in the stadium? The denominator was all about time or hours, right? So your units should just come right out of that. You shouldn't have to make those up. Should come right out of your numbers there. Okay. Little intro to rates. Doing okay? Fair enough. One little note that I wanted to throw out there to you. Starting Monday, or I don't see you Monday, starting Tuesday, calculators will be active for the whole rest of our class, for the whole rest of the year. On any quiz or test or classroom activity that you might do. I know we've held off on those for a while. Starting Monday, we're going to be getting into things where the calculators are really going to be an aid. The numbers are going to get bigger and uglier and that kind of thing. So the calculator will be very helpful. So please start bringing your calculator to class. And I just want to say this with everybody here. Your phone is not okay for your calculator. And can I explain why? You all get notifications, right? And it just, to me, it's just pure folly to think that you could get notifications from Instagram and TikTok and blah, 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 and whatever it is, and not get distracted, right? You're saying 1,275 divided by 4. Oh, I just got a notification. And like 3 minutes later, you're completely distracted, right? What was I doing again? Oh, yeah, the calculator. What did it have to? I got to start over. Do you see why that's just not good? Doesn't make much sense. So you need to have an actual calculator, no phone. Okay, cool. Hey, let's do our concept quiz. Let's do some awesome work on our systems. Make your forts again. Clear everything off your desks, except for that.